equations was? Like, it all should be written in your notes. What did we say a system was?
Two equations. And
two equations, two unknowns. Okay, so now we are starting this new idea that we can solve for two variables at the same time. And to do that, we need to have two equations. Okay, what did we say the solution to a system was? When we found that solution, what was it?
Intercept.
I mean, it is the intersection point, but what does it mean?
One solution.
That tells us how many solutions it is. So look up higher in the question part of our... Here, what does the answer represent? What does this mean?
Oh,
The X and Y value that what?
That make both true at the same time.
Right? It's making both of those equations true at the same time. So we are really looking for what can X be and what can Y be that makes both of these true at the same time. Yes, Shady?
I don't think I have two equations and two variables.
That's what a system is, right? That's up here of what a system is, but the answer represents the two equations being true at the same time. Okay?
I don't think I have that.
Do what?
I don't have that.
You didn't take notes with us on Friday, or you didn't keep it? You misplaced it?
Is it this one?
No.
I don't know what it is.
Okay, so we then looked at what the different options, types of answers we could have, right? So we said if we get intersecting lines, we would have one solution, and what would the one solution be? What did we say we would do? So if we have one solution, what did we say the solution would be?
Name the point.
We would name the point. And so we looked at example 1 here, and we graphed them both, and we found an intersection point of 2, 3. Is that correct?
Yep.
Okay. Option number 2, we said that if we graphed and we got parallel lines, what would our solution be?
No solution.
No solution. Why was it no solution?
Because
They never cross. So we said when we looked at these two equations in example 2, we got parallel lines. We did get a graph on this one, correct?
Yes.
Okay, my 2 classes ended in 2 different
Oh,
places.
we didn't do X3.
Right, we haven't done that one yet.
Yeah.
And why did we say, do you remember when we looked at these two equations, what made these two lines parallel? Do we remember?
The beats are different.
The B's are different, but the slopes are the same. So different B's, but the same slopes meant that the lines would never intersect because they were increasing at the same rate. So we got a no solution there. So the last one that we still have to look at is number 3. So number 3, we're going to just start without our graphing calculators at all. We're just going to straightforward say, what would we do if we were asked to solve a system? So what would we do first, Sam?
So 2y equals 4x minus 2.
Okay, so maybe we would notice that this isn't even in the correct format, and we need this solved for y.
So you're just gonna divide it.
So we're just going to divide by 2. Excellent. And once we got it solved for y, right, the rest of that equation and work didn't matter. So that took us here. Now what? Now I have them both solved for y, so what am I going to do next?
Graph that 1y.
Okay, so we're going to graph. How about this one
Negative
first?
1y. Oh.
-1. What does -1 represent?
The y-axis.
The y-axis. So on the y, we're going to go to the -1. It's our y-intercept, right?
And the 2 represents the slope.
The slope. So we're going to go up 2 over 1. And how many points did we say we would need to make?
All of them.
Right?
So you know for sure.
Enough of them so that we could figure it out for sure.
So it wouldn't be infinite many solutions.
Hang on, hold on. Okay, and then we said we would ignore the fact that we had graphed 1 on the graph to start with, and we would flip to the other graph. And where would we start on this one?
Negative 1.
-1. And I don't know why this pen isn't working, but you know, it's cool.
So
It's the same graph though.
Yes, it is. So we'll start at -1, and then up 2 over 1. Okay, so what happens?
It's
It's the exact same thing. So Vida, if it's the exact same thing, what did you say the answer would be? Infinite many solutions. Now let's talk about this for a minute. Vida, you seem to recognize right away that these were going to be the same line? What cued you in that these were going to be the same line? They're the exact same equation, right? So when we solve them both for y and we get the exact same equation, obviously they're going to be the exact same line. Now remember, infinite many solutions does not mean all solutions. Infinite many solutions means that there's so many solutions we can't write them down. Okay, so for example, if I were to make a point here,
that point
is
doesn't
that a solution?
No.
Why not?
Because it's not on
touching the
there.
other line.
Right? It's not on the line. The only solutions are points on the line. So is this a solution?
Yes.
Is this a solution?
Yes.
Is this a solution in the middle?
No.
Yeah.
Yes, yes.
Because it's still on the line, right? So even though it's not a point we made, it's a point on the line, it still counts as a solution. And how many points are on a line?
All of them.
An infinite amount of points. So that's why there's infinite many solutions. Does that make sense there? Okay, then I want to just look at a couple practice problems before I